Brian, you have to do a summary of what you heard in the last half an hour. Is it going to work?
It's absolutely going to work. In the last half hour to the hour that I've been here with these presentations, first, it's an honor to be here. And I feel in this past 30 minutes to an hour and the previous presentations have been nothing more than an affirmation that I have found my people.
So we are your tribe.
Yes, absolutely. And I made a promise to Mara to keep my presentation short. I have a habit of going long when I get excited. There's so many dimensions to get into. And I feel like all of these presentations, which were beautiful, have provided the essential components to being a teacher and a contributor to our communities. We have provided information, insight, and inspiration. Looking at the presentations that have been created, shown here, is that I feel it's been an insight to my own thesis, my classroom every single day. I am glad that I edited 95% of my regular talk out because the imagery has been, at least 75% of the imagery shown here today is what I'm introducing in my classroom and I surrounded my own thoughts with on a regular basis over the past 30 years working with the ceramic material. So it's exciting to be here and exciting to hear from all these professionals their own insight and the relationships that we all are finding at this, bringing to the same place.
I'm not going to tell anything anymore. Please, Brian, enchant us.
Okay.
Just to bring up the slideshow. So this is difficult to try and think about how to wrap in AI with analog technologies and how to bring in contemporary advanced technologies and engineering into my own practice. And I decided to take a narrowed scope in terms of chemical and material science within my own practice, but I'm going to touch base on some larger identities first. So I am a ceramic artist. I work with one of the world's oldest materials that has presented and established our civilization. The origination of a vessel that can carry water is what allowed us to leave the edge of a riverbank or a lake and move inland to create agriculture and civilization, which led to medicines. And so it's been a record of people and humanity. So as I've developed over my own practice over the last 30 years, both as a maker and an artist and a teacher, I've come to understand or have a love for structuralism. And while the basis of structuralism there's a definition in there, but the one that I have come to have an understanding with this is that it's the study of nature, the nature of things. And the previous presentation with the professor talking about fluid dynamics, everything in there was an absolute celebration of the things that I have found in my own practices and what I try to instill in students with the relationships. And so with structuralism and or structures, that relates to systems and how everything has rules and practices and order of operations. And they are all in their own rights strict and correct. But when we are engaging with that component of humanity and the moment and being present, it's about context. And in order to adapt in that context, we have to have a broader understanding of not just our field, but for me, as a maker, using this material of ceramics and being a teacher, I've gone through a Bachelor of Fine Arts program that was a liberal arts program where I've learned about the arts in writing and dance with performance. Into the sciences, I have a material science degree that is based in raw materials. But you can't just apply one set of rules. There's the adaptability that comes with both understanding of materials, but also intuition. And what I found for myself, and what I really try to instill with students, is there's the textbook, there's text, rules, understanding, and the textbook is right until it's wrong. And that's kind of the real world, is we have to start with the information, but then once you are there, you have a series of variables that you have to understand and react to. That's what I love about ceramics, is that it's one of the most reactionary materials through time, energy, and physical action. And so I started out as a potter over 30 years ago, but over time, I've come to realize that I'm a maker, a teacher, a builder. So I am run a ceramics program where I also am in charge of, it's a 7,000 square foot facility that's in charge of over 300 different raw materials, 15 different kilns, that 4 completely different types of fuel sources and atmospheres that are created, and teaching a generalized program to students that are both artists and non-artists, especially the scientists in the STEM programs. And hearing about all of this discussion of STEAM, over the last 15 years at my institution, we've had this ebb and flow of, when I first came in, STEAM was what we discussed. Then we changed the director and president, and that turned into STEM. All of a sudden, the arts disappeared, and we wondered where the creative thought went. And now we've come back full circle where we're into STEAM again. And I have a lot of my students, through my own understandings and experiences, and that I start with my art students, and when they graduate, they generally become scientists, and they go into STEM-based fields because of their understanding of solving problems, knowing that systems are not perfect and that no one solution fits all. And then the science students that are taking my classes, I adapt my courses to fit their understanding of research, variables, constants, experimentation, setting a hypothesis, and then assessing. Those STEM students end up becoming artists and business owners within the creative arts. And so it is this crossover. And I think there's a wonderful celebration how the practice elevates a broader understanding of theory. And so within my own work, I'm driven by Mariusz Drzesko, who we've worked with. I think we've known each other for about 16 years. We met in China, and these are some works that I made when we were together working in Fuqing in central China with the historical origins of many ceramic materials, but they are not as easily to manipulate or as plastic as other materials from other geological regions. Within there, so our connection with Mariusz, we immediately connected on sacred geometry and the science, the math, the systems behind form and understandings of perceptions. But again, that's only the beginning of something. Within there, you have to use your own perception, intuition, and experiences to find new forms, find new understandings, and new control of materials. And so these are some pretty dynamic forms that in China I was not able to produce within my first year there because the clay was not plastic, and there was a completely different technical approach to how students there and technicians are trained. And so I had to think laterally, and my understandings of material science allowed me to think about what's in the local grocery store to a massage parlor. And I would this material, for first year of making forms that are had this much movement to them, that they would crack and break. They were not plastic because the material geologically doesn't have that same plasticity and same chemical makeup. So by going to a massage parlor, I was able to get Epsom salts or magnesium sulfate, which is a material that we use for sore muscles or helping repair the skin. That same material can create a positive charge on the molecules, which allows the clay to become more plastic. And it also creates then, with an interaction of temperature and time, color, surface, and texture. And so what we're seeing here is that these pictures there is no formal glaze or finish applied to this work. This is a collection of raw materials that were embedded for a functionality, kind of a Bauhaus approach. And through that understanding of firing methods, fuel sources, chemical relationships, and personalities of materials, it's now creating its own finishes. That is, I think the most poetic way I've learned to discuss it is it's painting with fire. And so understanding the personality of raw materials beyond that of a picture in a textbook, and understanding how things with an uneven number of electrons allow other ones to bond. There's also how these things interact and move, and their interrelationships, just like how we interact with people. So there's the psychology and the philosophy and needing to understand sociology of how an environment is created to support an intention. And so with the work that's being pictured here, this is works that were fired in an Anagama wood kiln in Bali, Indonesia. These were fired with coconut and papaya and mango trees that are extremely refractory. And so I had to find other materials such as sugar is something that I bought from the local grocery store to add into my materials to help melt and solidify, to help make those materials more fluid so that they could allow the colors to then be exposed. And in works like these, we are seeing how the variation of color is coming from as simple as 5-degree difference of temperature shift in the flame. So we can create a chemical formula of these materials that are used. And I've gone to ChatGPT and asked it, can you give me a more balanced formula for this? Or can you give me predict a firing method in order to produce certain results? But I've always found that it's missing is the context of the 5 senses. And that's actually being present. And that's not to diminish the science and the text, but there's being present and learning those relationships and understanding how to not manipulate, but work with and gain that understanding. These are materials that are, I live on the shores of Lake Superior in central northern United States. These are all materials that have been hand dug and processed over the last 15 to 20 years. And so these are the materials that I've been going out and starting out working with the geologists, working with the engineers, the scientists in the region and my university to tell me where things are. But from there, I've got to go dig and handle and learn how to clean and separate and find out the intrinsic value that each of these materials hold. Because while they might have the same chemical formula, depending on the atmosphere and the context you put them in, they change. And so we're seeing works here. There are colors here that are coming from the National Lakeshore, where most of these are heavy metals that I've pulled out that have been leaching from the Earth's surface and pulling those out of the ground and processing those into different grit sizes and finding other local materials in order to help them melt and achieve certain temperatures. And it's the nuances and the quiet moments, just like in life. The big decisions I don't think are hard to make, but the small ones, the little things in life they're usually what make it so important and special. And so I'm learning how to create atmospheres to pull out and celebrate the personality of these materials beyond the understanding of the textbook itself. So one of my main backgrounds is kiln engineering, and laws of thermodynamics are something that have always excited me. And I started out in the sciences, found my way to the arts, and I've been going back and forth ever since for the last 30+ years. When I first got to my institution, the image on the left is the first soda kiln that was pre-existing, that fits and meets all textbook understandings of what a kiln should be. But in the process of learning this, and it was built impeccably. It's held for twice as long as a kiln normally holds. That is being induced in certain atmospheres. So the engineering or the craft in building was there, but the understanding of the materials and the atmospheres created were not effective. This kiln would cost over $1,000 to fire. It could not be put into a reduced atmosphere. It could only be fired in an oxidation atmosphere, creating a very limited palette of colors, a limited palette of textures. So it was expensive and, again, limiting in the freedom of expression. The kiln on the right is same materials, exact same cubic footage. So it fires the same amount of material. But this kiln that I designed takes $9 in fuel to fire, and it expands the entire range of colors and textures and temperatures that it can use. If you ask ChatGPT about how to design these kilns or how to fire them, they're going to give you the same formula, but they do not interact the same way. Just as we could look at psychology behind people and how we're supposed to interact with them, but we've all had different empiric experiences, and therefore we all have different forms of reactions and ways to respond. And you can't treat every individual that you meet the same way. You have to pick up on working knowledge and intuition and insight to the context of that moment. It's the same thing with kilns, where the kiln on the right that I built with my students, it can be every student that fires it that has not just learned to build the kiln, but then learn to interact with it, has different results because they have different personalities and they are addressing things different, and they all have value to it. But one student can have it fire in 8 hours and another student can have it fire for 24 hours, following the rules of what an AI system will tell you to apply to it, but that's taking away the sensitivity of touch and sound and smell. And so AI, when I've asked ChatGPT to provide me with firing systems or a method of approach, and it'll tell me gas pressures and the relationship of air to gas and things like that and timing. But you have to actually be there to be present to be able to feel the vibrations in the gas line, to be able to touch that ball valve, to move that, to smell the difference of an excessive amount of carbon within the fuel source, or a reduction or lack of that material. There's the sight and looking at color of the flame. And so all of those are these little sensitive moments that any kiln can do, but every single kiln through its materials and its age is going to respond differently. And every time I fire that kiln on the right, I have to adapt my understanding because it is at least 1 to 3 firings older. There is a buildup of material that changes the way things interact, and I cannot follow the same formula every single time. You have to be present and learning and listening, even down to the soda solution, which is a sodium bicarbonate that we mix with water and spray into the kiln. It vaporizes and it moves around all the forms that are in that kiln. So there's the thickness or thinness of the material, there's the quantity of the material, there's the stack, where things are. And so you get to control and predict where the movement is. Through chemistry, you can create the color palette, but it's just like almost like photography, is that you're capturing a specific moment in time, showing you that moment that cannot be repeated, even though it shares a same concept. With this kiln, one of the things to kind of denote that is over here on the left with the stack, there are those 4 holes. Those are called passive airs. The engineers of the university built this stack that was 15 meters tall because it fit their needs of the rules of OSHA, the operating safety hazard systems, what the school needed to allow this to exist. But that works completely against the thermodynamics and how the kilns fire. So that was one of the reasons the original kiln couldn't work. So through experiences of firing kilns for over 30 years and understanding how the flame actually moves, not just with theory, but actually within practice, I put these extra holes in those chimney, and we can see the color on the picture on the right as students are adding soda, and we can see the flame that's going up through that chimney. That's allowing us to control where the flame moves, the direction of it, the velocity of it, the placement of the kiln, and the length of time that it's there. So it allows us to offset the engineered reasons for a structure, but allowing us to make things now functional. So where it's a compromise in there. And I think that's life too, is finding ways to work within the needs versus desires. The picture on the left here is textbook neutral combustion. So this is the theoretical perfect balance of air and gas ratios. We can talk about that from the science world of what that means in a certain context, but to find that within the age of burners, the age of a ball valve, the different types of fuels that are used, the pressure and velocity of the movement inside those kilns. I have students that have been firing this kiln for several years, and not one of them can achieve that color in the same way that you might look at baking or mixing. You can be given all the same ingredients, but there's the sensitivity to the nuances, there's the environmental moisture level, there's your different sense of touch and pressures, and those things cannot be fully explained in the AI world. We can use that as an understanding, but we have to then actually understand and feel it in the real. And that's where we gain empiric knowledge, and that's that believed truth versus stated truth. That space in the middle is what pushes us forward, and that allows us to gain true understandings of the nature of a material in a context. So over here, I'm able to reduce that $1,000 plus cost of firing, but through this methodology, I'm able to drop that down to just sub $10. Which is a huge savings when you look at sustainable practices and use of materials, but it also produces more viable results. So within there, that allows us to create atmospheres, and what the student on the right is doing is pulling out what's called a test ring. And in this, I'm teaching arts through sciences, letting them understand the materials and basic formulas. So the picture here on the right are two rings. The more white one has been pulled out. That was the one that we saw the student pulling out, that's oxidized. And that's allowing them to see the buildup of the soda, the introduction to the actual atmosphere and what it's going to do to the glazes and the clay bodies. When it cools in a reduction atmosphere, that brown clay, or the brown ring, is from the exact same firing, exact same location in the kiln. So there's a relationship that people have to understand to predict, this is when I need to stop adding this material because I've now achieved the results that I want. And that numeric value of how much sodium bicarbonate to add or how much water relationship in there changes every single firing depending on the context of the, again, thermal mass of material, the placement of it in the kiln, and methods of firing. So they have to see the buildup and know that every time it's different, but it is that experiential information based and rooted in the sciences that allowed them to predict and create the final decisions. The picture on the left here, we're seeing where I'm giving students the 4 basic groups of what constitutes a clay body. And you could absolutely go to ChatGPT, and I have my students do that, say, how do I create a white stoneware clay body that can be fired to 1300 degrees centigrade? Or maybe it's, I'd like a red clay body that's good for sculpture at 1050 centigrade. But it will give you a formula. But there are thousands of permutations of the possibility in there that specifically rely on the context of what your desire is and the technology that you're using. So here students are choosing their materials, they're recording what their measurements are, and then they're seeing the physical results. So what's on the paper here with this image on the left is the tangible creation of that is that little vessel made by a student on the left. And from there, they can start to pick and choose, just like cooking, a pinch of this, a handful of that. Understanding the differences between black pepper and white pepper are not the same. They have very different profiles, and they can celebrate or they can diminish the flavor of a food very quickly. This is the kiln that we built 6 months ago over here at the ceramic studio. And this is based on the picture on the left is called a rocket kiln. This has been a movement over the last 10 years in the States that is looking at adapting old electric kilns and using a technology that was created in the 80s that was for wood firing and for heat production in homes. So we took that baseline technology and started to adapt it to the materials in the field. And it's allowing things to be fired where a wood kiln can take anywhere from 48 hours to 10 days to fire. This type of kiln is up to 12 cords of wood. This type of kiln we fired in 2 hours with 1 wheelbarrow of wood, and we achieved flashing color and ash buildup that can be achieved in a 48-hour firing. So there's the turnaround time, the efficiency of the materials, the use and sustainability of those practices, and the insight that students can gain to quick turnaround times. And again, adaptability, I think, is the big one, and that deals with being present, relying on science to a degree and the text, but then you have to use your understandings and also your environmental factors. So when we showed up here in Europe, there is not an excess number of old cylindrical kilns. That's more of a North American style of production. So here, Marius made this wonderful change, which has absolutely changed the way people are approaching this in the States and even on a global perspective. We took some of the traditional engineering of a arch kiln and applied that to the same J tube, which allowed it to be more effective, fired faster with greater results, which we didn't even break a sweat and we didn't even smell like smoke. It was a smokeless firing, which is also a very hard thing to achieve in terms of gaining color and surface and variation without that smoke. It has to upend the existing knowledge and principles. So that only comes from that experiential knowledge and starting with the text and then through experiences, understanding how to talk and relate to those materials. So relationships, it's the same way we deal with people and our own understandings of ourselves.
Bradley, thank you so much for this phrase of experiential knowledge, which actually gets together the, let's say, scientific knowledge, technical knowledge, and artistic knowledge. Thank you so much. we made it in terms of time, but we won't have any more time for questions. I will just very shortly give the mic to Septimiu, maybe to put up some a few ideas, and then I invite you to the lunch break. But it's going to be a short one so that we restart at 3 p.m. and we are back to the correct schedule. Septimiu.
Mulțumesc. Vă mulțumesc tuturor. Așa cum am prevăzut, miza e sus și miza e dată de radicalitatea soluțiilor pe care noile tehnologii le oferă la nivelul prelucrării și manipulării informației. Când pregăteam temele simpozionului, între noi ne puneam problema aceasta și ziceam, trebuie să contrabalansăm mergând la tradiție și să introducem termenul tradiție, dar iată că din locurile în care colegii noștri au pus accentul, rezultă limpede că suntem într-un nou moment în care trebuie într-adevăr chestionată noțiunea de tradiție cu tot ceea ce ea înseamnă. Și ne pare rău că ratăm șansa de a pune niște chestiuni în discuție pentru că suntem în casa făuritorilor de tehnologie. Merita să dezbatem chestiuni precum responsabilitatea lansării pe piața unor tehnologii, chestiuni precum ce înseamnă tradiția pentru făuritorii de tehnologie. Bineînțeles, aici intră noțiunea abilităților, a meșteșugurilor, ce se păstrează, ce este patrimoniu salvabil, ce este valoarea adăugată de care trebuie să fim conștienți în toate domeniile cunoașterii, nu numai în cele trei în care suntem implicați aici, la această masă rotundă. Dar eu cred că o diferență fundamentală care ne este așezată în față în acest moment din nou revoluționar pe linia evoluției digitalizării este faptul că dacă până acum tehnologiile răspundeau unor nevoi materiale sau materialiste ale oamenilor, acum democratizarea pe scară largă aduce în discuție manipularea informației cu implicații extrem de variate și care inevitabil va duce ca următorii făurători de tehnologie să nu mai fie numai inginerii, ci mai mult ca sigur grupuri heterogene și interdisciplinare și așa mai departe. Multe s-ar mai putea spune și îmi pare rău că nu pot cei din sală, dar dacă totuși cineva insistă, aș da cu... Nu. Mulțumim tuturor!
Mulțumim!